Good evening, ma'am.
Good evening. So let's start with the results. Hello. Rahul, I'm in the midst of a class. I'll call you after a while. No problem.
Good evening, ma'am.
Good evening, Anirudh. So first, let's see the results. After that, we'll take up the test. Finish up first 10. Shall we discuss the answers?
Good evening, ma'am.
Shall we discuss? Yeah, have you finished? A few of you have joined just now, but we'll just recall and then you'll be able to ascertain whether you're remembering these results or not. The integral of any constant will be constant times x. The integral of any power function, that power can be any real number, okay? Any real number other than -1. So the minute it becomes -1, it becomes a linear function in the denominator. That will become log of this divided by a. And log x, many students write the result as 1 by x. That's why I gave this. But actually, it's an unknown function, okay? So its integral has to be done using parts. So x log x minus x is the handy solution. This is like any exponential function, no? Exponential function, the integral is the same, but you have to divide by the coefficient of x. So a power x will be a power x by log a. Log a, when I say it's log a to base e, okay? 2 power 3x, can someone say?
Two power 3x by log 2 into 3.
Very good. 3 log 2. Yeah, so log 2 comes because of this logic and 3 comes because x is accompanied by 3. This is a popular result, no? Sine inverse. And this is also a popular result, tan inverse. And integral of sine x is minus cos x. Let me know how many of you got these 10 correct. Okay, because some of you joined late, I think that is the reason. Okay. Try these 5. Shall we see the results? But there is another equivalent result here. Does anyone remember? This can be had as an equivalent result for that. And similarly, we can have, does anyone know the equivalent result for this? If you don't know, you can create it, okay? Because cosecant is nothing but 1 by sine, and cot is nothing but cos by sine. So we can write this as log 1 minus cos x. 1 minus cos x is 2 sine square x by 2. And sine x is the LCM. That is 2 sine x by 2 cos x by 2. So sine x by 2 gets cancelled. So what you get is a simple tan x by 2. So probably some of you may be knowing these results, alternate results for these. They can also be derived. Okay. How many of you got these 5 correct? That is starting from 11 onwards, integral of cos x onwards. Yeah, many of you this time. So let's see if others. Yeah, from 16th to 22nd, can you complete? Hope you have completed. Amongst these, only these two are direct derivatives of functions. No? Like secant square, we know, is the derivative of tan x. And cosecant square is the derivative of minus cot x. So among the trigonometric square functions, secant square and cosecant square are readily integrable. But the others, like tan square, it's not readily integrable, but it will be readily integrable if I write it in terms of readily integrable functions. So I get this simply by using basic trigonometric identities. Now it becomes super integrable. Okay. So this will be minus cot x minus x. But then see sine square and all that, we need to use that half angle form, isn't it? I have to write this as 1 minus cos 2x. So square functions are not easily integrable unless they are written in the form of linear functions. Okay, that is the case with sine square and cos square. So half comes out. Integral of 1 is x. Integral of cos 2x is sine 2x by 2 plus c. Similarly, this can be written as half of 1 plus cos 2x dx. So the result will be half of x plus sine 2x by 2. And this, this is the very first result, no? Sine inverse x by a plus. So can you write the rest of them up to 30? Did anyone complete?
Yes, ma'am.
Okay. Yeah. Among the special results, what you need to observe is that all these special results are quadratics, either with the root or without the root, but they don't have x terms. No? So these quadratics are called pure quadratics. These are pure quadratics. Among the pure quadratic results, this one and this one. Okay, only these are inverse trigonometric results. The rest are all logarithmic. So having known this, this is a very plain result. No? X plus root of a square plus this. So this is log of x plus root of x square minus a square. See, here also I've seen some students writing this as x square. Okay, so that's why all kinds of mistakes are possible, slips are possible. Okay, so there is rigor in everything. So make a note of this. Then we have the last two also as logarithmic. So which is 1 by 2a log. Oh, this is tan inverse, no? This is tan inverse. 1 by a tan inverse x by a. These two are logarithmic. This will be 1 by 2a log a plus x by a minus x mod of this. This will be 1 by 2a log mod of x minus a by x plus a. So many students are curious to know whether there will be reduction in marks if they don't add c. Okay. What I'm saying is that the addition of c is very important in differential equations, because when I add c, that is when you know that the solution is a family of curves. So c plays an important role in that case. But whenever you integrate by default, if you add c, you may not lose marks, okay, in differential equations. That is the reason why we insist that you should add c. And how about this? This has got a pair quadratic, but in the numerator, okay? So what we should do is we should write a square by 2 and write the result if it were to be in the denominator. So a square by 2 sine inverse of x by a. And then x by 2 into the same integral, that is a square minus x square. Similarly here, a square by 2 into the result for this if it had been in the denominator. So this result plus c, and here x by 2 root of a square plus x square. This one has got, this is actually the same as the 29th, where a square gets replaced by minus a square, right? So that is the only change that we will incorporate in the result. So both are one and the same results, x by 2 root of x square minus a square. Okay. How many of you got all the 30 right? Number. Only 2 of you. Okay. So, but then you can overcome whatever weaknesses that you have. You still have time, but note that there is rigor in everything. Okay. So, let's not lose marks on account of basic results. See if we can do the first one. We'll discuss and then proceed to the next. Integral of e power root x dx. You're able to see? So, okay. All right. Which option?
C option.
Good job. Yeah, I think so. But what was your approach for this?
By parts.
By parts. Okay. But always remember general rule I'm saying. Okay, if E has a very bad power in the sense it's not linear. No, anything other than linear is bad for integration. Okay. So I need to get rid of that bad power. Bad power in the sense something that is interfering with integration. So how to make it good? How to make the bad thing become good? X is t square. Okay. So that root goes. That's the main idea. So root x will become t, and we have a very pleasant function to integrate. Did you see that? Root x has become t, so that's the main advantage of this substitution. And dx is 2t dt. But even now, it's not readily integrable. Always, if you take out the constant, it will give you a better perspective. Okay, remember that. But we know that this is exponential and this is algebraic, and therefore it calls for what? Parts. But parts, I've told you an easy method, no? What is it? Integral of this into the function that you need to differentiate minus integral of this into function that you need to differentiate. So this is the result. Okay. See how it works is that, for example, suppose if we have sin x into x. Okay. How does it work? You can use it in MCQ. That's why I'm telling you. What you need to do is, first of all, integrate this. You get minus cos x. And keep x as it is, minus. Integrate this. So you'll get minus sin x. And then differentiate. It will close. See whether you understand? I'll give you one more example. Suppose I have x into secant square x dx. This is readily integrable, tan x, into this function which will ultimately become 0 after a certain amount of differentiation, minus integral of this, which is log secant x, into derivative of this, close. Did you follow this? Raise your hands in case you followed. You can use this in MCQs. Okay, easily you can do. See, you can also use it if you've got something like this, integral of x square into sin x. Okay, what you need to do, first you put the integral of this minus cos x, and then put the function as it is, minus, plus, integrate this, minus sin x, differentiate this, 2x, differentiate this 2x. After that, differentiate 2x, you get 2. Okay. Now integrate, keep on integrating the first one. So these are all to be integrated. Okay, first one needs to be integrated. This one has to be differentiated. What needs to be differentiated is based on something that vanishes after a certain amount of differentiation. Invariably, it's the algebraic function. The other function is taken for integration, but it gets differentiated right away. In the very beginning, it gets differentiated, integrated. Okay. So integral of the one which gets easily integrated after the subsequent integrals, and then this function which is subject to differentiation gets differentiated as many times that you can. Okay. After that, it gets closed. So I think that's what we have used here, plus C. And then you can substitute back. So if you substitute back for t as root x, C seems to be the option. Okay, can you try the next? 0 to pi by 2.
And is it same?
Yeah, I think so. But I just wanted to know how you approach it. It's a simple problem, actually, but many students do some technical mistakes. What's 1 plus cos 2x is what? 2 cos square x, right? 2 cos square x. So root 2 will come out, no doubt. Integral of, what is the root of cos square x? Can someone tell me? What is the root of cos square? What did you write? I'm asking. Did you write cos x
Yes.
or something else? Huh?
Yes.
Oh, yeah. Actually, just to make it technically perfect, say root of x square is always mod x. Can you remember this? Okay. Of course, in this case, it doesn't make any difference. 0 to pi by 2, no? Cos x by default is positive there. So it doesn't matter. But had the limit been 0 to pi, your cos x will be affected. No, from 0 to pi by 2, it will be positive. From pi by 2 to pi, it will be negative. So it's better that you always remember that the root of x square is mod of x. Okay. Of course, in the next step, you can drop mod because cos x by default is positive in the first quadrant. So I can take it as cos x. I'm telling you this because there may be a problem which involves the root of something and I may merely take it without attaching the mod. That's why I'm telling you. But in this problem, it doesn't make any difference. So in this case, it is sin x. Integral of cos x is sin x between 0 and pi by 2. Upper limit, it is 1. Lower limit, 0. So pi by 2. Next one. 0 to pi by 2. Tan x dx by 1 plus tan x. What did you get?
5 by 4.
Good. Yeah. But actually, it'll be a good idea to, I think you might have tried it as such, but it'll be a good idea to apply property, no, for this.
I use properties only.
Property only. Yeah. So actually one can do without the property also, but for some of you, it doesn't strike that it may call for some property. So always be alert whenever limits are there. So there is always a possibility of a property being useful. Okay. And also it will be better if you express everything in terms of sine and cos. it becomes much better. Okay, of course you can do as such, but it will be easier if you express in terms of sine and cos. Apply property now. The property allows you to write x as pi by 2 minus x. So this becomes cos x. This becomes sine x and this becomes cos x. So adding 1 and 2, it's a very popular way of solving for use of properties, right? So sin x plus cos x, and you have a common denominator. That is the advantage of adding. So both of them get cancelled. So 2i is integral of dx, which is x between 0 and pi by 2. So that is pi by 2. I will be pi by 4. Okay. So remember this. You know what? Around 40%, 30 to 40% students, they forget to divide by 2. It's a very common mistake. Okay. So be careful. Fortunately, it's not given that option, but pi by 4 is correct. Can you try the next one? Does anyone know what is lattice rectum?
4a, ma'am, it's length.
Its length is 4a, but what is it, I'm asking? How do you define a lattice rectum? Okay, if you've not remembered, what is the focus of a parabola? Anyone? Oh, you have forgotten all regarding focus. Focus is at a comma 0. Okay. So what kind of parabola is this? Because see, knowledge about curve tracing is important, isn't it? Y square is 4ax is actually a right parabola, right? It's a right turning parabola or opening towards your right. And it has got the focus at A0. See, the lattice rectum is supposed to be the one which is passing through the focus and perpendicular to the axis. Okay. That is called the lattice rectum. It's a focal chord. It's a focal chord. That means a chord passing through the focus, which is perpendicular to the axis. So this is called the lattice rectum. Of course, some of you remember that the length of the lattice rectum is 4a. That's a different aspect, but you should know what a lattice rectum is. So he has given you a boundary. He has said that he wants the area of this parabola bounded by the lattice rectum and x-axis. So he has defined it very well. Okay, so this is the area that he is looking at. Okay, which formula will govern this area? To find this area, which formula will you use?
Y dx.
Very good. Because x-axis is one of the boundaries, right? So to find the area, what will work? Y dx will work. and x is ranging from, we know that the curve starts here, it ends here, and in the meanwhile, here x varies between 0 and a, y square being 4x. So can you integrate and let me know? What did you get? I think even last year board exam, the problem was regarding a parabola only. So you should know how to integrate it.
4a square by 3.
4a square by
3, ma'am.
3. I think there is an option like that. Yeah, maybe you're right. So let's verify that. Others can also verify. 0 to a, y is nothing but root of 4ax. So we can take out the constants. So what remains is root x. Root x can be considered as x power half. That can get integrated. X power 3 by 2 by 3 by 2 between 0 and a. So 4 by 3, a power half, upper limit a power 3 by 2. A power half into a power 3 by 2 is a square. How many of you got this? This is the correct answer. Very good, Shyam. Many of you got it. But suppose there is a slight variation. I bring about a slight variation. Supposing they say, find the area bounded by y square is 4ax and the lattice rectangle. Okay. What will be your approach?
2 times this area.
Yeah, because suppose they don't say x-axis as the bounding curve, then I think the lower part also should be considered. Okay. So there is a subtle difference here. Mind that.
None. 2 square units.
Very good. Very good. Correct. I was just thinking, because from 0 to pi, there are two ways of approach for this. One is a strong idea about what the curve looks like. For example, from 0 to pi, he's asking, we know at pi by 2 cos becomes 0, but at 0 it is 1, right? So actually the curve goes like this. So I'm sorry, the curve goes like this. 0 to pi by 2, and at pi, the value is -1. I hope all of you know this. At 0, the value is 1. At pi by 2, it is 0. At pi, it is -1. So there are two options before us. We want this, right? But due to symmetry, this area will be the same as this area. Okay? Because of symmetry. So what I can do, I have two options. I can find out the area between 0 and pi by 2 multiplied by 2. Okay. So let me find out what is the area that the curve occupies between 0 and pi by 2. That is nothing but sine x. Sin x between 0 and pi by 2. That will be 1. Okay, 1 minus 0, which is 1. So if I multiply it by 2, I get the area. That's one way of seeing it. Suppose those who don't know about the symmetry aspect, what they can do is that they can write this as this plus. When you go to pi by 2 to pi, what integrand will you write?
Minus cos.
Minus cos x. Because cos is negative there. That's what I was, particular about the area being positive. So that can be positive only if any branch of the curve that goes down, you have to take, for example, there is a curve here, y, some branch of it goes down, say from 0 to 1, it is up, and from 1 to 2 also it is up. From 2 to 3, it is down. Okay. Say this is y of f of x. Y is equal to f of x. It is still y is equal to f of x only. The same curve. But when you integrate and find the area, it will be 1 to 2 of f of x plus 2 to 3 of what? 2 to 3 of? It has come down. Did you see?
Yes.
Minus f of x.
Minus f of x. Yeah. From plus 2 to 3 of minus f of x. Always remember. Okay. Whichever part of the curve comes below the x-axis, y is negative there. Okay, so y will become minus f of x in order to make the integral positive. Or else you can write that as 3 to 2 of f of x. I don't mind. Okay, any one of these techniques. But the simplest way is to understand the symmetry and write this as 1 into 2, which is 2 square. Either way, whatever trick you remember, you try to do it properly. Integrating factor of this.
Root 1 minus x square.
Very good. Yeah, I think so. I think so. We had 1 minus x square into dy by dx minus xy is something. Of course, we don't bother because till this only is important for integrating factor, isn't it? For integrating factor, the first two only matter. But here, this dy by dx should be devoid of any multiple, okay, any factor. So the first and foremost job would be to divide throughout by even the right hand side, everywhere. Okay. So after this only, it will become P of x here. And it will become Q of x. These are proper P of x and Q of x factors. So the integrating factor is given by, is it root? No, it's 1 minus x square. Yeah. So integrating factor is given by, who remembers? E power?
P of x dx.
The integral of P of x dx. E power integral P of x dx. So E power integral, mind the sign, minus x by 1 minus x square dx. So I substitute 1 minus x square as t. So minus 2x dx is dt. So x dx will become, or minus x dx will become dt by 2 by t. Isn't it? That is nothing but E is still here, right? E is still here. So E half of log t. But the multiple of log actually becomes its power. Okay. That's why she said the integrating factor is actually t power half. T power half with t is nothing but 1 minus x square. So root of 1 minus x. So I'm interested in knowing how many of you got this correct? Root of 1 minus x square is the integrating factor. Of course, Aparna got it. Or Jessica also. I'm sure many of you would have got it. It's a simple idea only. but integrating factor is sure to come for you. Okay. Solution, simple solution may be asked. Try this. Which option?
B, ma'am.
Very good. Yeah, it is B. And do you all know how to make out what kind is this? See, the presence of XY, okay, the presence of XY here actually can make you suspect that, of course, here also. Maybe it'll make you suspect that it is linear in X, linear in Y probably. Yeah, it can be linear in Y. You can bring it to the left and realize that. But more appropriate method to approach this would be, it's not homogeneous. Did you all see? This is degree 0, this is degree 1, degree 2. So it can't be homogeneous. So either I have to try and separate this. Separation is the first method I'll try. Okay. Because separation is so very elegant. So I will try for separation. You know what? There are two ways in which separation is easily achieved. One is factorizing. Other one. Many students don't know this. Actually, separations are achieved by substitutions. Like, I think it works in homogeneous. If you remember, we substituted y as vx. Okay, after that, it becomes separable. So always remember, whenever there is some difficulty in the problem, okay, and if you strongly suspect that it is yielding separation, then probably you can try factorizing if it's algebraic, or if it is something else, you can always try substituting something. Okay, so that will work as an ultimate weapon. They may not give you such tough problems, but I'm saying that always works. Some kind of substitution will resolve this. But here, this is readily factorizable. Can you all see? Why I'm saying readily factorizable is that because y comes out from the last two terms. And here, 1 plus x is common. 1 plus x has occurred in both the terms. So 1 plus x into 1 plus y. After that, it's a question of separation. So dy must be accompanied by term of y. Dx must be accompanied by term of x. So it becomes variable separable at this stage. So log of mod 1 plus y is equal to x plus x square by 2 plus c. Hope you could do this. Let's see the options. In the options, there are two of them. I was looking at the options, two of them which look almost alike. Okay. Just pay attention because you worked so hard on concepts and computation. Just for want of rigor, if you don't see the answer properly and choose the correct one, you'll feel miserable. Okay. Note that here, C is accompanied by Y. In our solution, C occurs just like that. No, C is just here. It's not accompanied by Y. So the correct option should be B. How many of you chose this? B option. Okay. Of course, many of you said that in the beginning itself. You would have done, I'm sure. Okay, next one. Next one is a very obvious thing.
Not defined.
A, ma'am.
It's not defined. It's not defined because it is sine of y dash. Had it been sine of y, I would have chosen the degree to be 2. Did you all see? I don't mind the presence of sine y. I don't mind the presence of sine square y. Anything, e power y, all those things are okay. But if it is sine of some derivative, it wouldn't be a polynomial in the derivative, so its degree becomes meaningless. Okay, that's it. So, assertion.
A,
Good job. Yeah. So this is correct. Okay. I was looking at it. Reason is obviously correct. And dx by 4 square plus 3x the whole square, right? So what will be the result? 1 by a tan inverse of x by a. Okay. But then instead of x, I have 3x. So it should be accompanied by 1 by 3, but it comes as a multiple. So 1 by 12 tan inverse 3x. Okay. So it's come. Yeah. Yeah, sure. Hope the argument convinces. Next one.
Looking for the online classes and all will get time to when the classes start, right? Thank you.
Ma'am, option A.
This is obviously true, and therefore this is the inverse process. So hence it is that. Did anyone get all the 10 correct? All the 10 MCQs. Hope you are keeping track of how you do. Okay, just for self-assessment and just to know where you stand. Okay? Okay, no one got it. Probably there was some hitch somewhere. You can rectify it, no problem. Look at the next one. Okay, but I think he has given you the answer itself. Should be easy. What are you thinking? Are you planning to apply some property? By calling this as 1 and applying the property will make it become 0 to pi. I'm sure all of you must have done this. You know what? In property problems, you'll be pleasantly surprised or you'll be happy to know when you apply the property like this, okay, instead of x, if you put upper limit minus x, they give you half a mark. And in the next step, if you write it correctly, okay, this is pi minus x, right? And tan of pi minus x, note that pi minus x will all be in the second quadrant and all these become negative there, okay? So if you put this another half a mark, and if you cancel the negative sign and write this as 0 to pi minus x into tan x by secant x plus cos x. By this time, you would have got 1 mark already without integration, okay? Without integration. So call this as 1, and what you got after substituting upper limit minus x as 2, then you add 1 and 2. If you add 1 and 2, you get 2i. And in the numerator, denominator being same, my attempt is to add the numerators. So So 1 and 2 are added, right? In 1 and 2, secant x plus tan x, secant x plus cos x. Yeah, secant x plus cos x is LCM, common LCM. And in the numerator, I have x tan x in equation 1 and pi minus x tan x in equation 2. They get added. X tan x gets cancelled, so pi comes out. Tan x by secant x plus cos x. After reaching this stage, what do you do? How do you make it decently integrable? What do you do?
Express in terms of sin and cos.
In terms of sin and cos. I think these will occur to you. Naturally, these will be occurring. Take, multiply throughout by cos x. But right through, the limits always are there. Okay, we didn't affect the limits while using the properties. The limits are not destroyed. Dx is not destroyed. I think after that, the problem is actually cos square x in the denominator, no? I think it is inviting you to substitute cos x as t. So minus sin x dx as dt. So that the numerator is actually minus dt pi. I would like to know whether you are trying to change the limits or you are retaining the limits as such. What is your plan? You can change the limits if you want, because the substitution statement, accordingly, you can change the limits, because here the limits are from x is equal to 0 to pi, right? At x equal to 0, your t is 1. When x equal to pi, t is minus 1. So you can change it in terms of t. So it will be handy later on to substitute after the integration. And because of the negative sign, I'll be shuffling the limits. Initially, the limits were 1 to minus 1. I'm going to shuffle them as minus 1 to 1 and make the integral positive. Upper limit tan inverse of 1. Lower limit is minus of minus pi by 4. So that will be pi into pi by 4 plus pi by 2. That is pi square by 2. Is it I or 2i?
2i.
Yeah, because sometimes they may not give you the result. No, in this case, of course, they've given you the result. That's because it carries only 2 marks. Okay, so that you can check your result. But invariably, such problems come without the answers. So in that case, you should be alert. So I get pi square 2i to be pi square by 2. So I will be pi square by 4. How many of you could do on your own? Very good. Excellent.
They can be expressed in terms of f of x and f dash of x, right?
Very good. Yeah, it reaches that state, isn't it? F of x plus f dash of x. But what you need to realize is that this is your f of x and this is your f dash of x. So your answer must be e power x into f of x, okay, between the limits pi by 2 to pi. That being the case, f of x being minus cot x by 2. Can you substitute the limit and see what it is? What is it in the upper limit? What is it in the lower? Who remembers what is cot pi by 2? Cot 90?
0.
0. Very good. So upper limit collapses. Lower limit, pi by 2, isn't it? So x by 2 will be pi by 4 and cot pi by 4, cot 45, that's 1. So e power pi by 4 into minus 1. That's what it is, no, in the lower limit. But there is a minus sign outside. So minus of minus becomes plus. So it is e power pi by 4. This is not 2i or anything, isn't it? I don't think we used any property as such. We merely integrated it and we substituted the limits. That's it. Okay.
Isn't it
E
e
power
power
pi
pi
by
by 2?
Hmm?
Isn't it e power pi by 2?
Oh, I'm sorry.
Ma'am, initially also the function was expressible, right, ma'am? If we split it as 1 by 1 minus cos.
Yeah. If you remember, if you can realize it, nothing like that. No, you can split it like that and you can realize that it is actually the derivative of the second function. No, but that's not easy for many to realize it. So it's better that you reduce it in terms of half acts. That will be
Okay.
easier for many.
Okay, ma'am.
Try the next. Can someone answer? What type is this? Does it call for substitution? Does it call for parts? Does it call for partial fractions? What is it? We know partial fractions are applied on algebraic functions mostly. So the presence of log x rules out that being partial fractions. So I was thinking probably we can substitute log x as t, then x will become e power t and dx will become 1 by x. But x would have become e power x. No, x would have become e power t. That's not a good idea. Okay. I think parts will work best for this. But if it were to be parts, I have to find out what the involved functions. One seems to be logarithmic, other seems to be algebraic. The code word being isolate. L comes first, isn't it? So I need to take u as log x and dv as 1 by. I'm sure many of you would have realized this already and you're working on it, but I'm just telling you that it works well with parts. Can someone tell me what is V here? dV is this much. What is V?
Minus 1 by 1 plus x.
Minus 1 by 1 plus x. But we know, we have seen lot of examples where you have consecutive terms arising in the denominator, and we have always succeeded in splitting them as the smaller one followed by the bigger one. Always remember, when you have two consecutive terms, we can write that as, right? Two consecutive terms. Because the limits are positive, I didn't bother to put mod. Did anyone get this? Is this okay? Anyone? How about you, Anirudh? Anna,
Mom,
did you get this?
I didn't get this one, but I followed what you did.
Oh,
One number
okay.
varying for but log 3/2 instead of log 2.
Probably you might have combined in a different manner. That's fine. You would have probably combined log 3 plus log 2 and written as log 6. All that is possible. Okay, but broadly, we are substituting upper limits and lower limits and combining them. So using properties of law, we can combine in any manner. But I think they will go through it carefully and find out whether the answer that you gave is equivalent. Okay, so that's not a botheration. Look at the next problem. I would like you to tell me what kind is this. dy by dx is x plus y whole square. What type is this? Is it homogeneous or linear or separable? That's what you have to tell. This actually, when expanded, is this, right? You may think that this is second degree. This is also second degree. This is also second degree. So can I not address this as homogeneous? Okay, this thought will come. But usually the characteristic of the homogeneous is that dy by dx will be some function of xy, all right. But this should be homogeneous of degree.
0.
Yeah, it should be a degree 0. So degree 2 is not permissible. So it's not homogeneous. Okay, it's not homogeneous. And the presence of x square, y square rules out it being linear either. So it's not linear. So we have the last resort. What is that? It should be separable. But what did I tell you? Whenever you strongly suspect something to be separable, there are two things which will work. One is factorizing and separating this as f of x into g of y. Then separation is easily achieved. Okay, the right hand side should be factorizable as a function of x into function of y. Then separation can be achieved. In this case, that kind of a factorization is ruled out. Then what did I tell you? What is the second method? You should try and substitute something. So let us try and substitute x plus y as z. Okay. Can you try afterwards? You can differentiate this. Can you try and separate now? I think it will be easily achievable. Was it achievable? After that, it's very easy. Once you resubstitute in terms of z, you can see that this is dz by dx minus 1. Right hand side is z square. So dz by dx is z square plus. I think separation has been achieved. How many of you got this? Good. Hope you understand. These are exceptions rather than rules. Okay. So you may get a problem like this. So what you need to remember is that you need to first examine whether it is homogeneous, because that's very easily detectable, right? There are tests also to endorse whether it is homogeneous. So if that is not working, probably you can think whether it is linear or not. In this case, that was also ruled out. So we tried factorizing, it didn't work out. And therefore, we had to substitute. So these are ultimate weapons with you. Okay, remember. X minus y cubed into dy by dx. Tell me, which one of these?
LD.
Yeah, very good. Yeah, LD. LD in what?
Y, ma'am.
But y cube is there.
X, ma'am. X.
Very good. Can you all rearrange like that? Did you realize it's definitely not homogeneous? 1, 3, 1. Okay, not homogeneous, and it's not yielding separation also. So that being ruled out, you have to examine. So if it is LD in X, which is strongly suspect, you have to rearrange it as let me see whether you achieve this. What we can do is, we have got dy by dx here, but we want its reciprocal. So I think we can do away with this. Therefore, multiply by dx by dy, because this is destroying the linearity of x, no? So unless and until I have dx by dy, it's not possible for me to arrange it in this fashion, right? So multiply throughout by dx by dy. So this is what it is. So what I'll do is, this is what I desire. No, this is what I desire in the first place. So let me put that in the first place. What is that I want in the second place? In the second place, I want the term of x. So let me put that in the second place. What is that I want on the right side? I want the function of y there. Okay. So this is actually somewhat linear in x. But what prevents it from being linear in x perfectly is that this intruder. Okay, this y shouldn't be there. So what should I do? I should move it away. The only way of doing it would be to divide throughout by y. Divide by y and achieve the linear differential equation form of x. How many of you achieved this? Let me see. How many of you rearranged properly? Very good, Vidyut. Yeah, Vinay also. Very good. Yeah. So I think now you will be in a position to arrive at the integrating factor. What is the integrating factor?
Y.
Y. I'm sure you would have finished the problem by now. So it is e power integral 1 by y dy, right? Which is nothing but e power log y, and therefore the integrating factor is y. So x into integrating factor, this is the solution, right? Solution is x into integrating factor is integral of q of y into integrating factor dy. So xy is integral of y square into y dy. Here, you just mind the presence of what? C. Okay. And after that, you can write x to be y cube by 4 plus c by y, provided y is not equal to 0. So under that assumption only, we are proceeding. But I think in the problem itself demanded y not being 0, right? Otherwise, the problem would have collapsed. Of course, we'll mention that in the end. How many of you got this correct answer? Okay, I can see that many of you are very thorough. Three marks. Evaluate 2 to 4 x square plus x by root of 2x plus 1. To 4 x square plus x. Oh, and this has a funny, characteristic. The derivative of the numerator has occurred in the denominator, but that's of no use actually. No. What shall we do for this? It's not partial fraction. It's not parts. It ought to be substitution. But what is substitute?
Root of 2x plus 1.
Yeah, just 2x plus 1 as t, even that will do, right? Because if I make it monomial, see, the problem is because I have under the root a binomial. So I face some issues there. Okay. So by this, I can actually get everything in terms of t, and also dx is easily replaceable. Can you try? See what the integral becomes. Was thinking probably we can alter the limits as well. Because the limits were meant for x. So t becomes 5 here. X was 4 here. It's easier than we thought it was. Actually, no, it's reducing to a pleasant number. See if you get this, and after that we'll proceed. Is this what you get? I get t power 3 by 2. So t power 5 by 2 it is. And t power minus 2. So t power half it is. Upper limit 3 power 5. Lower limit. You got something like this. 5 power 5 by 2 will be actually 25 root 5, right? 25 root 5. So it will be 5 root 5 or 10 root 5. 10 root 5 minus 2 root 5 will give me 8 root 5. 8 root 5 will give me 2 root 5 ultimately. So the second part of that is 2 root 5. And this one will be 3 power 5. 3 power 5 is 243. 243. So 243. 486 by 20 minus 3 by 2. Somewhat like this. Did anyone gets anything like this? Very good. Very good.
But I took root of 2x plus 1 as t and it.
Root of?
2x plus 1 as t and it.
Okay. Yeah. That's also a good idea. Yeah, it makes sense actually. 1 by 2 root of 1 by root of 2x plus 1 would have become dt, no, Anirudh?
Yes, ma'am.
So the final answer should be 30 gets subtracted, no? 456 by 20 minus 2. See, always remember the manner in which you simplify. I mean, you might think all that is trivial, but in the exam, no, those who succeed or those who get 100 are those who are very good in computing and do it very fast. They do it fast without any mistake. Okay. Such children actually stand very good chance of getting 100. They wouldn't make any numerical mistake. Okay. And they're very alert. They're very focused. And they're not tired of doing problems. Okay. All these qualities. Okay. Next one. Under root cosecant x minus 1. Obviously, I think one will be tempted to write this as this. Let me see who comes out with something that is somewhat useful. I want the root to go in the numerator. What is the best method of doing it?
Sine pi by 4. I mean, minus x by 2, that formula.
Okay.
I'm rationalized.
Very. Yeah. I was waiting for this suggestion. I think now it's very obvious what you need to do. Can you take it forward? Let me see how you do it. Even though it almost looks like, what is it? Partial fractions. It's not. Under the root, you have factors, so that's not clicking. So what do you plan to do for this? Under root, you have a quadratic, and that too, it's not a pure quadratic. What do you do?
The square.
Yeah, we can. What did you say?
Complete the squares.
All of you remember how to complete the square? Coefficient of t is 1 multiplied by half, and then add and subtract its square. Okay. Take the coefficient of the linear term multiplied by half, and then add and subtract its square. So that would definitely complete the square. So let me see who recalls what is this. This is nothing but t plus half the whole square, right? Minus half the whole square. What result? I think we recall the results. Who remembers?
Log x.
That one. Log. This looks like x square minus a square. No, that is nothing but log mod x plus this. X plus this. So it will be log mod There are so many details to remember, of course, but remembering is due to your involvement. No, those who are involved will always remember. Those who are focused and those who want to achieve things will definitely remember. So all that you need to do finally is to resubstitute for it. Okay? How many of you could do it even before I did, even before I gave you clues? How many of you knew how to proceed? Not many. Okay. Fine. Of course, once we give the clue, it becomes easy, no? But I'm sure all these will strike in exam. See, I'm sure there is something called exam luck, okay? But there is also called passion and determination and fire. I don't know, somehow the problems that eluded me in the class, okay, all that will come in my exam. I remember when I was a student, I never used to leave any problem. All the solutions used to come to me because I was dead determined. Okay. Not a single problem I wanted to leave. Okay, this one is something that all of you can do, right? Can someone tell me what it reminds you of immediately?
Partial fractions.
So can you determine A, B, C and tell me? Let me. I think we had dx5. How many of you know how to split this?
Now is it 1 plus x square, 1 plus x and 1 plus x whole square?
Very good, Vinay. Yeah, this is linear repeated factor. No? This is a linear repeated factor. This is non-factorizable quadratic. Non-factorizable quadratics are accompanied by linear functions and linear repeated factors are accompanied by constants. Remember, for these two, LCM is the higher power. Now, without making mistakes, can you fix A, B, C, D and tell me? First things first. I put x as -1. So terms accompanying A and C and D, all of them vanish. So we get B. What is B? Good. 1/2. After that, what is your next step? How would you determine the others?
X as 0.
Very good. X as 0. So, B being half, A plus D is half. Okay. Anything else?
A plus Z is 0.
Very good. How do you get that?
Cubes on both.
Compare x cube. Compare x cube on both sides. So 0 is equal to a plus c, because this is the only term containing cube and this is the only cube you have. Then how about x square term? Shall we compare x square term? Tell me all the x square terms. I think there is one x square term over here. Yeah, x square into a. There's another x square term here, b. And cx is accompanied by 2x there. So, and d is accompanied by x square. But a plus d we fixed already, remember? A plus d was half and b was half. So that fixes c immediately. So that fixes a immediately. And that fixes d immediately. How many of you got these values? Some of you would have already solved, I'm sure. Very good. See how fast some of you. Very good, Jessica. Okay, so I think we just need to substitute all these. No, d is 0, fortunately. So a was half. So half by 1 plus x plus d. Capital D was half. Half by 1 plus x the whole square. And d was 0 and c was minus half. Okay, can you just integrate this and let me know what it is? Let me check whether what you got is indeed what I'm arriving at. Half log mod 1 plus x minus 1 by 2, 1 plus x minus 1 by 4 of log of 1 plus x. How many of you got this guy? Check and Sai Siddharth, are you getting the answers?
Yes, ma'am, doing it. I think I made a mistake in the middle or something.
So determining these constants, many of you do brilliantly in your test also I've seen. So I'm not worried actually. Next one, find the equation of the curve that passes through 1, 2 and satisfies this differential equation. Okay, dy by dx is this. Can someone tell me what type is this? Dy by dx is minus 2xy by x square plus 1. Huh?
Linear, ma'am.
But is it not very easily separable? Because the right hand side is already product of a function of x into function of y, no, Aparna?
Yes, ma'am. Sorry.
That's what we will be actually aspiring for, that the right hand side should be, our prayer would be that the right hand side is already factorized and given. I think it's offered in a platter for you. Actually, it's already factorized and given. So I think it is very easily separable. Okay, don't miss that. So you got x square by, I think we had something like this. 2x by minus 2x by x square plus 1. Of course, we can also attribute it to y minus y. Okay. This is something like, always remember, if your dy by dx is already like this, I think we are very fortunate. And they are very easily separable. I think you can do it. And the curve passes through 1, 2. Come on. Curve passes through 1, 2. So this detail is given for fixing C. Can you complete it and tell me C value? Integration is very simple. Fixing C only is a challenge. What did he get C value? To be? Did anyone get this? Log of 2 power log 1 by 4. Is it okay?
Ma'am, I express C as log C.
So it will be easier for us to combine, no? So let us substitute for C here. Minus log y is equal to log of x square plus 1 plus log 1 by 4. So that it is possible for us to combine. They would expect you to arrive at the equation of the curve this way. So you better combine the terms that you got in terms of log. So it will be x square plus 1 by 4. And if I drop log everywhere, I get x square plus 1 by 4 is 1 by y, or y is equal to 4 by x square plus 1. Of course, x square can't be minus 1. So I think you have a real curve here. Did anyone get this already? This is fine. So always remember, when there is already scope for you to factorize or it's already factorized, you have nothing much to do, okay? Because it's very, very conducive for separation. So. The next one, can someone tell me what type is this? Dy by dx.
LD and Y.
Dy by dx is minus of x plus y cos x by 1 plus sin x.
LD and Y.
Very good. Yes. Yeah, it's easily brought to that form also, no? So this is like something like p of x, and that's also conducive for integration. And this is q of x. I think one can easily make out what the integrating factor is. Can someone tell me immediately what is the integrating factor?
One plus sin x.
Very good. That's it. 1 plus sin x. If you substitute the denominator as t, numerator is becoming dt, right? So it's like having e power integral dt by t. E power integral dt by t. That is nothing but e power log t. E power log t is t. Therefore, it is 1 plus sin x. So the problem is very easily solvable. Y into integrating factor is integrating factor of integral of q of x into integrating factor. Oh, that is also becoming so simple. So they may give you problems like this where nothing much needs to be done and the solution is arrived at in easy steps. See, always remember your board exam papers are not tough. They are intelligent. Okay. So they make you think. So that's what it is meant for. No, good to be in a system that demands a lot from you and tests whether you are original, analytical, all these. Okay. I hope this is fine. Is this what you get?
Yes, ma'am.
Okay. Yeah, I would like you to do this and tell me how you would approach this root of 1 plus x squared by 1 minus x squared. Anything comes to your mind? Sri Lakshan, can you suggest something? This is a big hint. Root of 1 plus x squared. Vidit, can you try? Subhitra. I'm sure she can think. This is so very obvious, no? How do you make it divide of the root? I want root of 1 plus x squared to become a perfect square. What substitution can achieve that? What should I substitute? You know it in inverse trigonometry. What do you do?
tan theta.
Good. Okay, can you all get down to it? Can someone suggest what to do afterwards? This is striking me. Check if this is okay. Because always in books, they give you very tiring solutions. But this will be very simple for you. Check if this is fine. Split it also. I adjusted the constant so that minus 2t square and plus 2t square will go. Okay, check if this way of splitting is fine for you. Of course, you can do in various ways, but I think this is the elegant method of doing it. After that, you can find the integral of these and substitute for t. Is it okay? How many of you followed this? Let me see. Raise your hands in case you follow. Very good. Yeah. See, following something is one big thing, but ideas have to strike you also. Okay. So keep getting exposed to problems like this. And then these carry 5 marks. Okay. Can you attempt them yourself? I'll send the paper. This is, I think, is there in the miscellaneous exercise that I've given for 5 marks. And then 3 area problems. Okay. Try them also. And these will be for 20 marks, right? So test by checking whether you are able to do these problems. I'll send them in the group. Is it fine? Tomorrow, shall we do one cumulative paper? Is it okay?
Yes.
Okay. So tomorrow, I think from tomorrow onwards, you can start cumulative papers yourself because you need to adjust your time, right? So, and then probably if there is anything that you find very chronic about any topic, you can go through that topic again. Okay, revise the topic again and then try the cumulative papers once again. But I think while doing the cumulative papers, you will yourself know, okay, where your problems lie. So you can you can figure out, okay, the topics where you're weak at and then work on them, try the the cumulative papers once again. So writing that would be a very good idea. I think tomorrow, day after, you can be doing only cumulative papers. Okay. So only then you can finish problems on time. So tomorrow we'll do a mock paper, but I want you to participate more and adjust your timing also. Okay. Tomorrow fact.